Hey everyone, welcome to Math Spellbook. I'm your host Peter, and basically we're going to continue on with basically trying to learn partial differential equations with a little bit of differential equations, the stuff that we actually need from differential equations to learn partial differential equations. But you know, sometimes like we probably will have to backtrack and probably get back into differential equations. So I think for today, I will probably just take some notes on actually starting partial differential equations because we actually have some generalities here. So I have to organize this. So first off, I just want to separate the book from my notes. So let's try to see if we can do this. So I don't think we need the menu, so we can shrink that. And maybe we'll reduce the size. I do have some supplementary textbooks with me, just in case if we have to backtrack to differential equations. Morning, Ann Stunky. How's it going? What's the best part of your day so far? MSB? Oh, you just made initials for my Twitch name. Thank you very much for that. I was like, why you say MSB? And then I was like, oh, I had to think about it. Alright. So, obviously, I have not done all of differential equations. I've only done, I think, like up to, I think, first order linear differential equations, but I barely remember the other stuff after the integrating factor. So you can call me Matt Spellbook. You can call me Matt Spellbook or Peter, whichever you prefer. So whichever you prefer. But yeah, like, what's the best part of your day so far? And Stunky. Hopefully you guys don't mind me reading out loud from the book. Okay, let me see. I'll just turn the music down a little bit because I do love this music, but at the same time, like, I want to make sure that you guys can hear me as well as the music. And if you guys just basically want to study on your own and just want to have an atmosphere but no sound, you know, you're more free to mute me if you like. Okay, so let u be equal to u x, y, z, ... be a function of several restricted real variables. X, Y, and Z, ... and recall that partial derivatives, right? Respect to the x values. That I remember, yeah. Actually, I I think where I stopped at Calc 3 was like, I stopped with the distances between planes and lines, but then like I skipped around and I basically was like, oh, partial derivatives, no problem. And then I learned partial derivatives that way. Multiple integrals I probably need more practice with, but I know you do the inside integrals first and then you do the outside integrals next, but I think it could go either way. But I usually like doing the inside integrals first and then doing the outside integrals last. That's my thought process on that. But I mean, you guys can tell me which process you guys like to do with multiple integrals if you're already past that point. Okay, in order for a partial derivative, okay, I can write over here. Okay, I just want to make sure that chat doesn't mess up like my writing process. If it's in the way, I'll be sure to move chat. I'm not sure that I can discuss the best part of my day here, but I had a good chat with friends this morning. Nice, nice, nice. Yeah, that's fine. If you don't want to reveal that part of your day because it's like more personal to you, you know, you can just basically give like the abstract. Like basically it's like, oh, I just talked to some friends and you know, that's it. And I was like, that's good. That's a good part of your day. But I'm glad to actually read that from you. Actually, and Stunky, I'm wondering, oh, I almost forgot. I forgot to put the timer on. And I think I'll just disengage my model so it doesn't distract us. But and Stunky, I'm like, because I know you also do, like, you're a grad student, right? Because I remember I dropped into one of your streams once and I saw that you were doing a lot of coding or programming. So I'm just like wondering what you're researching. Let's see, order of the partial derivative is the same as the number of subscripts for the function of if the values. So if the values of the functions can be made arbitrarily close to up by a full up, is continuous up to all points. So for all non-negative integers, k is a function of u is said to be a ck function. Slightly off, but both counts. The coding was writing in LaTeX. Oh, okay. Do you mind if I ask what you were researching? Because I'm guessing if you're typing LaTeX, you're basically just... Oh, I'm not a student anymore, but that document is some research on computational... Oh, commutative algebra. Oh, nice. Which branch of math does that revolve around in? Number theory? Or is it mainly combinatorics? I don't know if I'm saying that right. So I think that's in boxes, so I guess we'll write it for... Whoa. Yeah, well, for a non-negative... Wow, why is it so, like... Can I make it smaller than that? That's pretty thick. I guess I have to write nicer. Reduce the size a little bit. If I can't reduce the size of my pen, I'll reduce the size of the way I see it. Okay. People are pretty lazy when they say CCA. Sometimes it means algebra that is computational applications, which is what it should be. What it should mean. Sometimes it means combinatorics that has algebraic applications. Oh, okay. And that's mainly just pure math, right? Like not applied math, right? Or is it both? partial derivative of u exists and is continuous. Okay, so for non-negative integers of k, a function u is said to be a ck function if every kth order partial derivatives of u exists and is continuous. So it has to be continuous, and and the partial derivatives have to exist within the kth order. So what does C represent actually? What does it say? Let's see. Continuous at a point P. So what does C represent in this case? Is it just a set? Let's see. A function is a C0 function if and only if it is continuous. Quite theory. Oh, okay. I see. Let's see. The notation U is an element of CK is used to indicate that U is a member of the set of CK functions. It is standard fact that U is an element of CK, implying that U is also an element of CK minus 1. Or CK minus 1. I probably should have said that. For k is greater than 0. Okay. For C2 functions, you recall that. Oh, okay. More generally, the order in which one takes k or fewer derivatives of CK immaterial. Okay. Okay, good. It's not. Oh, it's slightly. I hate it when it slightly jumps to the next page when I just wanted to lower it a little tiny bit. Why did it suddenly get darker? I didn't highlight it. Let me see if I can just... Yeah, for some reason it got darker and I don't want it to be dark. Let's see. We have assumed that the above function u is defined for all values independent variables. The function is a certain region D. Let's see. Wait, what was... no, wrong side. So that was just a box, so I guess we're given our first definition. Partial. function u such that k is the greatest of the orders of the partial derivatives of u appearing in the equation. Okay. So we also have another, so we should underline this. Solution of a kth order PDE thought I could be clever and do that, but nah. Well, where did that come from? Okay, so what does this say? Let's see, solution of a kth order partial differential equation on a specific region D is ck function defined on the region D such that the PDE is satisfied at all interior points of D. If no region is specific in advance, then the solution of the kth order partial differential equation is a ck function defined on at least some non-empty open region where it specifies the PDE. Okay, so on a specific region, define on the region D, such that all the interior points of D, so no region is specific in advance, then the solution of the kth order partial differential equation is ck defined at least. So I'm guessing it basically it's like probably everywhere within D, like inside D actually. There are many functions. Energies. Let's see. Spherically symmetric gravitational potential. That's an example. Oh, they even go over the Poisson equation. I don't know if I'm pronouncing it correctly. Let's see. We also have Laplace. Okay. So let's see. dr partial derivative. The square root of, yeah, that's the distance, like, I mean, that's the magnitude of the vector. And then let's see, harmonic functions, other solutions. Oh, they even give the heat equation. Yeah, I remember Sascha, who is like in our Discord server, like he was teaching me about the heat equation actually. He was also teaching me a little bit of eigenvectors and eigenvalues with it. Let's see, we got a DE, PC. So I gotta figure out what DE and BC is. Actually, let's see if we can look at the problems that this section covers. Get a better idea of what we're looking for. Okay. So CK functions. So we have to learn those. Linear PDEs form LU of F, where LU is a linear combination of the unknown function u, and its partial derivatives are made up of the order n, where the coefficients of f is given as a function of independent variables. If f is equal to 0, the PDE is called homogeneous. Hey Tyrion, how's it going? It's sunny again, time to do a walk. Nice, nice, nice. Is that the best part of your day so far? Let's see, classification theorem. The classification theorem asserts that every second order linear partial differential equation with constant coefficients where the unknown function has two independent variables can be transformed by a change of variables into exactly one of the following forms. Okay, so we got a generalized wave equation, parabolic, T of T. So we got the hyperbolic case, the ecliptic case. Like I was like losing words there. Let's see, form a generalized heat equation, parabolic, and the form degenerate case. Superposition principle. The superposition principle or property asserts that if u1 and u2 are solutions to the linear partial differential equation, Lu is equal to F1 and Lu is equal to F2 respectively, then for any constant C1 and C2 is a solution. Okay, in other words, okay. Green's function, okay. Green's function and their associate integral operators are used to represent solutions of initial and boundary value problems for linear partial differential equations or ordinary differential equations. Okay. So, show that the given function specifies the accompanying. Verify the following functions or solutions. Show the following. Solve the heat equation. Show that it's so this one has 20 questions. Okay. So this is Green's function and operators. Oh, they even talk about black holes here. That will be interesting. Let's see, operator to Green function. I'm working my way backwards, so that way it doesn't seem too overly bearing. Let's see, an operator is a prescription which assigns each suitable function some new function. For example, suppose that LU equals F is the case. So, for example, the Laplace operator. Yeah, I'm familiar with this one. You learned this in Calc 3, I remember. The way I learned this was not through Calc 3, it was through a vector book. That I have not seen before. Thus the Poisson equation is... okay, equals to F and F of this. To solve the equation, such as log of x equals c, or recall to simply operate on both sides the inverse. Yeah, which is you use E. To solve the Poisson equation, one might accept finding the inverse operator. Okay. It would simply on both sides to obtain the solution. Oh, it's a triple integral. Interesting. But then again, if you... yeah, I usually do like inside in. Hello Zach, how's it going? Happy Monday. What's the best part of your day so far, my friend? Yeah, I'm trying to basically learn like the basics of like partial differential equations, like see how they work, see how far I get confused. Of course, like I haven't taken Calc 3, like, but I am familiar with like concepts like the gradient curl and the divergence. Of course, I haven't gotten into things like Stokes' theorem or the divergent theorem or the theorem of line integrals. PDEs can't be challenging for sure. Yeah, I'm just trying to expose myself early. Because, like, I already exposed myself to differential equations, like, I think first order linear. But, like, I didn't want to, like, waste, like, too much time, like, mulling over the problems in section 1.1, so I felt like I should read 1.2 and just basically just go through my thought process out loud with you guys. But what's the best part of your day so far, Zach? And also, actually, I should give you a shout out, Zach. And actually, Unstunky, I should give you a shout out too, actually. So, Unstunky first, since Unstunky was first. So, be sure to give Unstunky a follow, guys. He usually basically goes over his research during his streams and explains some awesome math. Zach is also an awesome math streamer as well. Be sure to check out his like his streams for infinite series as well as in linear algebra as well. So check these guys out. They will teach you a lot of math. And trust me, they are not boring individuals. I guarantee you of that. Not like your typical like stereotype of a math like teacher. They are very exciting streamers, I assure you of that. If you love math and you love learning. So let's see. I didn't even know the gradient had an inverse, but then again in math I shouldn't be surprised. So I'm guessing, yeah, so the inverse would probably be the derivative. No, the integral, because it's the second derivative. Yeah, it's the second derivative, so it would have to be the integral. I wonder why there are dashed lines there. Does that mean it's like, these are treated like the derivatives? I'm guessing. Is G... Oh no, maybe they're different coordinates. Or like different, like, yeah, maybe like different coordinate systems. Let's see. Observe that when integration with respect to, yeah, X line, Y line, and Z line. I don't know how they pronounce like the dash, or maybe it's like X dash, Y dash, and excuse me guys, sorry. C dash is performed. We are left with a function X and Y and Z, which definition is a F is a C1 and is 0 outside some ball. Then armed with the appropriate tools, one could prove that is the solution was example of the integral operator, i.e. the operator B. Integral operator, huh? Interesting. Oh, X bar. Okay. Thank you, Zach. Thank you for correcting me on that. See, this is why I have a lot to learn, guys. Let's see. What does the C represent? Actually, like... Yeah, I've been wondering what's the C represent in this case. Because the definition basically says a partial differential equation of order k greater than 0 is an equation involving an unknown function u, such that k is the greatest of the orders of the partial derivatives of u appearing in the equation. And I know the second definition that I've read, where is it? It's all the way at the beginning. Yeah, here we go. A solution of the kth order PDE on a specific region D is a CK function defined on the region D such that the PDE is satisfied at all interior points of D. If no region is specified in advance, then the solution of the kth order PDE is a CK function defined on at least some non-empty open region where it specifies the PDE. C as in C1. CK means you have k derivatives and the kth derivative is continuous. C1 means continuous and all derivatives of order 1 are continuous. Oh, okay. Oh, Megamorph. It's good to see you. What's the best part of your day so far? I didn't see your name clearly because like Zach's name is also blue on my screen. So like I thought it was Zach basically saying that, but welcome. I was in Penn Center's chat, heard you responding to it. Oh, okay. Okay. So basically C represents like all the derivatives. No, it's okay. It's okay. I just read whenever I see something in chat. That's fine. It's okay. No need to apologize. Sheesh, yeah. So I'm guessing C represents like basically like I guess it means continuous practically. The best way to summarize it. The best part of my day is made breakfast, which was definitely tasty. Nice. What did you have for breakfast? You can't just say it's tasty and not. Yes, C sent for continuous. Okay. That makes sense. And I'm guessing D represents like a region within, well, since we're talking about partial differential, it could represent either a surface or a plane or whatever, right? Because it says Pacific region of D, which I'm guessing it's either a plane or a surface of something. Had rice and a salmon burger. Oh, nice. Was the rice like part of the bun, or was it like just on the side? Yeah, D is a region. Probably comes from a simple case where the region would be a disk. Oh, okay. Sheesh. They're already bringing us into the abstract already in this. Alright, let's look at the first example. Maybe I'll get a better idea of... Because, at least they show examples here. Let's see, spherical symmetric gravitational potentials. In Newtonian pre-Einstein theory of gravity, at a fixed time, the gravitational acceleration vector, force per unit mass, is okay, like minus the gradient of u, where the gradient of u is right is the gradient function of u, called the gravitational potential. You obey the second order PDE, okay, where rho is equal to rho x, rho y, z. Is the density per mass per unit value of the matter at x, y, and z. And g is the gravitational constant. Okay, that we are familiar with. One can also interpret u in other ways. For example, I as the steady state temperature distribution in a solid with internal heat source, density proportional to rho, or i.e. As an electrostatic potential whose negative gradient is the electric field produced by a charge density proportional to rho. In any case, equation 1, which is this one here, is known as the Poisson equation. Special cases when rho is equal to 0, 1 is better known as the Laplace equation. Suppose that we seek a solution u x, y, z of the Laplace equation, which is symmetrically symmetric in the sense that u x, y, z only depends on the distance. Okay, that we know, that we at least know. Origin 0, 0, in other words, equal to fr. Okay, so r, I'm guessing, is a vector function here. For some function, yeah, for f of a single variable, r is greater than 0. Also, I guess r is supposed to be a scalar in this point. Yeah, or distance. Use the chain rule we have. I specifically made a rice bowl when I said burger, I mean patty, no bun. Oh, okay. I'm not that fancy. Oh, okay. No, because I know, like, sometimes you can have the rice as the bun, you know, if you have, like, a burger. Actually, I haven't had, like, a burger that had a rice bun in... Actually, did I ever had one? I don't think I ever had one, actually. Now that I'm trying to remember. But then again, I think I had it once, but I just barely remember. Okay, let's look at this example here. So we have u of x, df equals where r ends. So the square root of, right? So that we have oh, okay, so they basically use, yeah, they did use the chain rule for differentiating that. Let's see here. So the derivative of fr squared. Okay. We see a similar expression which equals 0. So we have this and this. So I think these cross out because they're the same here. This is two is right. Right, gr is equal to the derivative of fr. Equation becomes separable or a linear ordinary differential equation. Whose solution, so where c and k are arbitrarily constant, hence the general spherically symmetric solution of the Laplace equation. Wow. I don't know what a rice bun is. I've heard of potato buns. Yeah, like I think like what they do is that they make rice like sort of like a it's like sticky rice, so they basically make it into like a bun shape, and then they I think they fry it up, so it's like has the consistency of a bun, but it's just made of rice. Like I think like they if you have like a teriyaki burger and then they have that, it tastes really good. Because I also heard that they also make the same buns like ramen noodle buns as well. Like it's I think it's well, I won't say it's a new thing, it's been out for a while, but I think some like, you know, like very like I guess like very like, I don't want to say cool, but I guess like very like hip places that sell like burgers are trying to do that, like just to be like kind of like show like, I guess like edginess to their food. Thus the only spherically symmetric solutions that are defined elsewhere are constant solutions. Which give rise to a zero gravitational or electric field. Of course, one does not expect to find any gravity or static force at the distance anywhere, okay? And then it goes to escape velocity. Wow, this section is like, it really does go into the weeds. So I'm guessing there's not like really like an absolute, like, I guess you just basically have to like look at a partial differential equation and like assess what it's actually telling you. And then you have to actually use like certain techniques. Now I see why like, because I always wonder why is it that like an iconic, when you go to sites like Khan Academy or Paul's Online Notes, like they teach you all the way up to differential equations, and I'm like, where's partial differential equations? Don't they teach you that? Now I see why like I guess sites like that don't go into partial differential equations that much, because I can see the way they explain it. It's like, wow. It's like the way they explain it, it's like they kind of give like I understand like some parts, but at the same time it's like I feel like, wow, I feel like I don't know where to start here. I think that's how usually most math students go through when they learn proofs for the first time. It's like, oh, I don't know where to start. Unless, I mean, maybe that's when they're in real analysis. I'm not talking about an intro to proof class. I think with intro to proofs, you kind of like, I guess once you know like things like sets and I guess like messing with the integers, you find a way to know where to start, I guess. Like, you guys can correct me if I'm completely wrong there. Yeah, because so far, like, even the examples are like, wow, it looks like a very huge hodgepodge. Not that I'm complaining or anything, because that's how math is usually. Like, when you look at something and it looks like completely like over your head, that means there's a lot to learn here. Yeah, I haven't been writing much because I'm like looking at the book and I'm like basically like, okay, what information can I take from this? Okay, PDE, BC, IC. What are those? Is that, oh, maybe it's initial condition, boundary condition, and what's DC? Domain condition? Let's see. Probably it says it right here. Oh, here we go. Let's see, the IC, I think the IC is initial condition. BC is boundary condition. But what does DC represent? Oh, here we go. Yeah, boundary condition. Okay, IC, initial condition. Alright, what does DC represent? I mean, I think D is supposed to be like domain or something. But domain condition? I've never heard of that. Certain region of space. Okay, so why is this boxed here? In Chapter 3, we will derive and study the heat equation in simpler one-dimensional setting where U depends on X and T. One example of the initial boundary condition values. Okay, so and T is more, right? I don't see DC. I saw DE. Oh yeah, it is DE. Sorry, DE. Yeah, it's supposed to be DE. My bad. DE is which is differential equation. Probably, yeah. Hopefully I don't become a page zombie. Because I'm like looking at this and I'm like, wow, like now I see why people get confused with partial differential equations. Like it just seems like it introduces you to like a lot of like ideas. Not that I'm complaining. It's just that, wow, it feels like I don't know where to start, like to actually understand how to like solve them. Don't worry, I can't read either. That's fine. Let's see. A linear nth order partial differential equation is a PDE which it can be put in the following form. The left side of the equation is a linear combination of unknown function u and its partial derivatives up to the order n, with the coefficients which are given functions of the independent variables. The right side must have something given, function f of the independent variables of the function f is initially 0, the linear is homogeneous. Okay, I remember that homogeneous and ordinary differential equations can have like two different types of meanings. I know one is basically the homogeneous a homogeneous equation is like an ODE that is equal to 0. I forgot about what the other homogeneous means. Let's see. In general, second order linear partial differential equation for an unknown function, u to the x, t is, okay, q x t r x t, a to t, where q and f are given functions, probably in constants. Okay, so it's linear because you have the derivatives here and the functions are acting as like the, I guess, Even though they're not constant terms, we can think of them similar to that. Are not all 0. Okay, if f is 0, then it's a second order homogeneous linear partial differential equation. Okay. Alright, well at least that I understood. I think homogeneous can mean y over x is a constant. Hey, Femvox. What's the best part of your day so far? We'll probably do problems in the next study session. Let's see, the generalized wave equation, the heat equation. So they introduce like the main equations like really quickly. The classification theorem. Consider the second order linear partial differential equation. And it's break time. Bing. Bing, bing. I'm glad you guys hear it. I don't know why I don't hear it. I have it set up the way I usually do. That's odd. But, you know, as long as you guys hear it, I am not bothered by it. I will be right back, guys. Just give me 1 second. Alright, we're back, guys. Oops, don't want to have the study timer going. I forgot that basically when I disengage, the timer restarts. So I guess I'm going to have to count 15 minutes on regularly. So I'm going to set a clock so that way, because I think we were on like 14 minutes, so we got a clock. Timer. We'll go with 14 minutes. Okay. All right, I have it on my phone, so that way I'll know when to get back into it. Let's see. I guess the best part of my day is just having a day off from work. Nice, nice. Let's see, not much. Just waiting to see if a student gets back to me about having a lesson today. Oh, what type of lesson? Oh yeah, I forgot. Megalomorph, you're a math tutor, right? I mean, I've read a little bit of your paper. I found it very, very interesting. He's working on learning how to do proofs. Oh, okay, got you. Like, is it an intro to proof course, or is it like real analysis? Yeah, actually, I was like reading through your paper, like I had to like look up a lot of stuff during the introductions phase. Like, I felt like I sort of like can visualize what the math was talking about. At the same time, I was like, okay, so like I wasn't sure if the math was supposed to like help solve like certain problems within, I guess, like within like physical problems in a mathematical way, or like was it supposed to be a mathematical idea that relates to an actual physical system? That's the one thing that I wasn't sure about in your paper. But I had fun looking up the terms, actually, because I was like, oh, I guess thanks to AI, like, you know, whether it be on Google or ChatGPT, you know, like, I'm glad they explain it in ways that I can actually visualize it. So it's like, oh, okay, so that's what it means. I mean, that doesn't mean I understand it, but at the same time, it gets me a better visual on how it works, if that makes sense. He's in high school. I had helped a friend who did a small mathematical thinking course. A student is doing an application to a summer program. Oh, okay. I see. Well, that's good that you're helping them. Because the thing with this is that, like, with math proofs, like, I still am very, very, like, noob at those. Like, you know, like, I actually bought, like, I bought, like, a new, abstract algebra book. And what I heard good things about this book. It's called Abstract Algebra, A Student's Friendly Approach by, Laura L. Dosriez, and Anthony J. Dosriez. Like, I don't know if I'm pronouncing their names right, but apparently in this book you can learn, because in the first chapter they cover things like sets, mathematical statements, compound statements, proof techniques, operations on sets, relations, functions, binary operations. I actually have the book next, like, literally with me, so I'm actually looking at the table of contents right now. Introduction of groups, spectrometric groups on degree n, divisibility properties. They have a lot of content in this book. Of course, like, you know, I have to actually read it, but the way the chapters are set up, it's like they actually give you example questions, and they actually give you the answers to those example questions on what it means. And I think they also give you homework problems at the back of each chapter. So I think this, because I actually saw a review on this book and they said that it's a really good book for self-study, so I felt like, oh, why not? And it's worth like $16, so I was like, oh, okay. So I just bought it and I looked through it and I was like, oh, this is interesting. And oh yeah, like, they do give you review questions. They give you 10 of them actually, which is not bad. And they give you like homework questions, which I don't think have the answers to. But I think they expect you to know what to do with those. Like, basically, like, how to get the answer, or like get the answer yourself. To be honest, I really don't know the context of the problem I was looking at. KC equations come from conformal field theory, but I don't actually know conformal field theory. I was looking at it because my advisor told me, oh, okay. I mean, like, it looked pretty cool. Like, the way you're, like, I think it's because, like, you're actually writing a research paper. I thought it was pretty cool that you were able to layer your thoughts in such an organized manner. I mean, like, I honestly don't know what it's like to actually research stuff on your own. You know, like, to actually be in university and look up different types of papers and read all types of documentation, and then you have to put all that in a research paper. And it ain't that the way. I mean, you're supposed to learn a lot of stuff, I guess, when you do research. I mean, the thing of it is that, like, I think the thing that you can't do on your own with research is, if you're doing it on your own, like, without a university to back you up, is just access the databases that the university has, because they pay like I think like a good subscription fee for those. But of course, like, I think like there are free resources that you can access, like Archive or something. There's lots and lots of reading and hope things are relevant, than trying to apply what you know to what you're working on. It's a process. Yeah, I think, like, for me, when it comes to like learning, trying to create a better learning strategy for me to like learn the math I need for like physics and like learning enough physics to actually like apply complicated math to. I think that's what I basically am. I think that's sort of like a life intention that will never go away from me. Because on our Discord server, oh hey, Fizzbuzz, what's the best part of your day so far? Not that I know what that is or condone using it, of course. Sci-Hub. Oh, Sci-Hub. Oh, okay. I never heard of that one. I think I'm familiar with it, but I've never used it. I'm only familiar with Archive. Let's see. Because I have to keep track of the time. Okay, we have 6 minutes of break time left. But hi, Fizzbuzz. They have tons of free PDFs of paywalled articles, those poor academic publishers. Oh my gosh, yeah. Yeah, I mean, like, the internet, like, is basically able to access a lot of stuff. So, you know, what do we got? Sci-Hub and, LibGenesis, only get you so far. Some things are just too niche that nobody has uploaded it anywhere, and you need your library's physical copy. Aw, that's unfortunate. But, you know, yeah, you know, the internet can only get you so far, right? It's like when you try to look for a PDF of a book and you expect them all to be online, but they're not. Especially the old books. It's like, sorry, you have to actually access it through your university library. And it's like, but I'm not a university student. Tough luck. Tough luck. It's like, oh man. But you know, I think that's what Discord is also there for. You know, like if we have like a big math community and like on any type of forum, there's usually someone that is able to access that information for us. You know. So let's see, because I did say we had 6 minutes left, right? Yeah, we have 4 minutes. Okay. Yeah, I think like the next study session we'll do actual problems. We'll probably like cover like differential equation problems, because I think like there's 2 parts to. Because I think we gotta practice like second order linear differential equations, which are these. But yeah, like the thing of it is that I remember like when I was like learning the history of Einstein, like basically he would just go to the library and he would just research all this stuff by himself, along with Mileva. Mileva would like help him like, I think like a ton with his research actually. I remember like I would find videos of like people basically saying that Einstein stole his work. I don't know if that's true or not, but at the same time, it's like, you know, it just pops up on my YouTube feeds from time to time, and I'm like, you know, like, if that's the truth, like, you know, as disappointing as that is, or is it just like basically like the same thing as like when people say that the Earth is flat? I don't know, because like whenever I get feeds on YouTube when it's like, you know, like Sabine, I think Sabine Hassan, I always forget how to pronounce her last name. But like, if you guys are familiar with like Sabine's like science news channel and stuff, like the way she talks about like academia and everything like that, I'm like, dang, like, you know, there's like so much dysfunction within like, I think, every branch of like society when you think about it, like, because like it's not just only in like politics, it's also within like academia and all that stuff, and I'm like, wow, it's like so much like disorder. So much disorder. And like, you know, I don't blame them, because there's like different like viewpoints on how to look at it, because like, you know, the public will only like give scientific funding if they feel the scientific funds are being put into something that's either like interesting or something that they feel as if the public will actually support. But of course, like, you know, like many people would prefer to believe in the many worlds interpretation than say the Copenhagen interpretation. Or maybe the opposite is true when people believe that, oh, there's only one universe and there's only the Copenhagen interpretation to understand within quantum mechanics. But, you know, that's like my take on it. My V2 model. Okay, there we go. It looked kind of weird. I had to like move it a little bit. Okay, how many more minutes do we have? I think 2 more minutes? 1 minute left, okay. 1 minute left, and then we'll probably work on some second order linear differential equations. But, you know, like, I think with the advent of the internet, there's always going to be difference of opinion. Quantum mechanics are such a minefield. Yeah. I mean, I guess in my personal beliefs, I do like to believe in the many worlds interpretation. But at the same time, if it's proven that it's absolutely not true, then, you know, I will have to take that. It's the same thing with string theory. If string theory is not proven to be the theory that many people think it is, and I think most likely it's probably not. Because even Edward Frankel, like a mathematician who really believes that there's a mathematical world out there, he feels that string theory is a complete failure. And I just take that. And I think, like, that's why I'm more into the maths, because, like, when you deal with other dimensions and stuff, mathematicians, they don't care. It's like, oh, if it's other dimensions and stuff, I want to play with it. But with physicists, it has to be that exact thing, or else it's just completely wrong. People should just have fun with it. Yeah, I do. Yeah, I think that's why I'm more mathematically playful when it comes to these ideas. String theory was a tremendously success for math. Yeah, a huge failure in physics. Yeah, like that's why I think, like, for me, if I had to choose either one of them, I would probably choose to be a mathematician, because I think I like physics because it gives me equations to play with, or like ideas to play with. But when it comes to like mathematics, I feel like the sky's the limit. I think like with physics, it just gives me equations to actually toy with, to give like realistic parameters that I can visualize. I don't know what to make of Ed Frankel. He asked some very basic questions on Twitter that are covered in very basic quantum field theory books. I think it's because he actually is a trained mathematician. Because I think like I connect with Ed Frankel in some ways because he got into math because of quantum mechanics, and like that's how I got into like math and physics. Actually, is because I wanted to learn physics because I just want to learn the equations within the math of the subject. But when I started learning things like, you know, sets and I guess the basics of what math proofs are, I think that's when I started to become more mathematically curious. Okay, so before we start our next study session, guys, I will just take a quick dash. So I will be right back. Okay, I'm back, guys. So I will turn my model off so it doesn't become too distracting, and we will start the timer. And I think we're gonna cover linear second order linear differential equations. So I think I got confused on this first one here, because they do have the answers in the backs for selective answers. At least I think they have the answers to number 6 here. So let me just go over here. We'll scroll down, make ourselves some space. Okay, so number 6. Find. Okay, so I think we're just gonna pull this over here, so that way we can just have the whole screen before us. Where's my mouse? It disappeared on me. Okay. So I think we'll just erase this part here. Oh, we got somebody here. Let's see, here we go. What'd you guys type up? A lot of QFT isn't fully formalized, or so I've been told. What is in textbooks isn't necessarily significant for mathematicians. I know mathematicians worked for a long time on things like renormalization, and there are multiple competing models for QFT. Gotcha. I will start a timer. Well, just be synchronized. I remember some of the work of Kevin just trying to formalize stuff is interesting. Oh, interesting. Interesting indeed. Hey Famish, how's it going? What's the best part of your day so far? So I want to see where my pen is. Oh yeah, I was doing something on my other screen. Okay, so my pen's right here. Okay, I just want to make sure that you guys can see everything, because I know chat is on the other side. Sorry for distracting from the... No, it's fine. It's fine. Like I said, like, whenever I stream, right, if I read something from chat, like, that's not on you guys. That's basically just me just trying to make the atmosphere more like we're enjoying ourselves and we're just, like, here just chilling. So, for me, like, I look at study streams as, like, it's not like I say, oh, I have to be, like, in absolute concentration mode. It's more like I'm doing something, but at the same time, I'm actually doing it with you guys, so we can enjoy each other's company while just like learning stuff. So don't feel like you're distracting me or anything. So we got this. Oops. So we got A, which is equal to 0. Okay. So, from what I've learned about second order partial differential equations, I mean, like, linear second order, second order ODEs, is that you have to turn this into this, so it becomes like this. Now, the one thing I have to figure out is, like, how do I turn this? Because I'm so used to it being like three things, like this. Why? Like something like this? Because obviously you would probably try to find R and do like the quadratic, a quadratic there. But with this one, I have to do it with just one. So... And I think I remember what the answer was, but I'm trying to figure out how to get to that answer. I'm just exercising for a bit, since I can't focus. Ah, okay. I don't know much what Franco has done with physics stuff. I usually think about geometric Langlands when I think about him. Yeah, he always talks about the Langlands program, which I think is pretty cool, actually. Second order ODE with constant coefficient. Yeah, because I think when you integrate this with x, you're supposed to get a constant on the other side. Like I think I managed to get up to this point. Yeah, because then we can get r squared, and then we get this plus c, and then we get c on the other side. Or do we not need that c since we have a c on the other side, actually? I hope to tune into one of your streams soon. Oh, you're gonna... Let's see. Let's see what we got here. Oh, you need to go Megamorph? Oh yeah, I just saw it right now. take care of Megalomorph. Thanks for chilling with us. We're always glad to have you here. Take care. I hope to tune into one of your streams soon. Do you also have to go, Fizzbuzz, or you're just saying goodbye to Megalomorph? Not quite. Second order. Yeah, I did that. Yeah. So do I actually need do I need the C over here? I don't think I need it. Do I? Well, actually it's supposed to be homogeneous, so maybe we need that so we can just subtract C on both sides to get it to 0. And then we have this. Oh, maybe I have to think of it this way. So if that's our, so wait. Because for some reason I keep thinking that it's going to transform into this, which I don't think is right. Unless I'm thinking... Huh. I thought I was going to be clever for a second. So you end up in a situation where R2 and is equal to 0, and since can't be 0, then R2 is equal to 0. So you have been in a situation where right, yeah. And then since can't be 0, then R2 has to equal 0. Yeah, because it says find the general solution. Do I have to solve for x? I get a feeling I have to solve for x for some reason. And that just yields a trivial solution, so you try something else. Yeah, because I remember what the answer was. The answer was like, I think it's supposed to be y equals x c1 plus c2. I think that was the answer. The one thing I don't like about this book is there's no bookmark. So I actually have to... what is this page? 33. So I have to... Why does it keep highlighting when I just want it to, like, go down? Okay, why isn't it loading up? Okay, here we go. I was like, why isn't it loading up the pages? Yeah, because it only has selected answers. So if we go up here, here we go. So number 6, here we go. Yeah, it's something like this. I'm trying to figure out how they got that answer. So hopefully I can get out of here before I see the rest of the answers, which I don't want to do. Just use a trivial solution. Y is constant, and then integrate xy so that xy's. Just use the fact that the derivative is equal to 0. So this is the first derivative, yeah. Yeah, I mean, like, because this says the second derivative is equal to 0, and then basically the first, I guess the quote-unquote first derivative is equal to 0. So thus we have to integrate again. Oh, okay, maybe that's what I have to do. So, oh, yeah, because, like, then we probably need this constant here. So, let's erase this first. Erase this. Okay, so we get this. And, yeah, oops. Did not mean to do that. So that would equal a constant, and this is equal to a constant. So basically we have to do a constant by a constant. Okay, maybe that's why. So I guess we probably don't need that. Yeah, so, and then we integrate this side by x. Oops. Because I forgot it was the second derivative, not the first. So then, like that. Then we're given this. Which in turn turns this into this, plus another c, so c1, c2. Yeah, I mean, that's practically the answer. And when we think about this, if it's just... the derivative is c1, and this is c2. I mean, we did get it. Yeah, I'm just basically reciting my thoughts because, like, I'm trying to understand what you're typing, Tyrion. At the same time, like, when I first read it, I'm trying to, like, reconnect the dots. Like, I'm probably overcomplicating it because that's the way I can basically paraphrase it in my head. That's the reason why it seems like I'm making it probably too complicated than the way it is. Because I'm trying to find the connections myself as well, so that's why. I mean, we did get the answer we wanted. It's just that, I wonder if I did something wrong here. That's the thing. Right, yeah. Yeah, I see what you mean. I see what you mean. That makes sense. Oops. Oh well. We already know what we're supposed to do, so... Right, yeah, and that would be why, yeah. Alright, now I see what you mean. For some reason... like, I thank you for helping me with that. At the same time, I felt like, wow, like, I'm really bad at getting instructions. Because that's the thing with me. Whenever I see something, I actually have to, like, analyze it and see it for myself, but I never make it the most easiest. Like, whenever I do stuff, especially when it comes to, like, playing games or, like, doing math, I bet, like, a lot of you are like, no, it's right there. It's right there. Like, you're probably screaming at the screen at me, and I'm like, oh my gosh, like, what am I doing wrong here? I don't see it. It's like, I always think that everybody else sees it, and I never see it. The method you used only yields a constant solution, so it's not good. Okay. When the roots are all 0, is the time to find something else. Okay. Let's see, this is a second order. So... I mean, yeah, let's do it the way, I think, like, for me, I just don't like, let's see. So we don't have an R, so we can't factor that out. So we can factor out the... So then basically, like, either... So this can't be 0, because then it'll be 1. So then the only way that can be right is if R is equal to, for that, so... For the next one, you use the auxiliary equation. Okay. Yeah, that's what I figured, because, like, because I remember I was learning the heat equation from Sasha from our Discord server, and, like, basically, like, there was a differential equation there was a second order differential equation that popped up, and it was like, how do I solve this? And I never knew, and I didn't know how to solve it, and he explained that, oh, when you do it, you have to do, like, an auxiliary equation. I'm like, oh, okay. Yeah, if I don't see something, guys, like if you're trying to help me, I will get there eventually. Just be patient with me. Because I know a lot of people are, like, really, like, want me to get to the right answer, or, like, basically want me to get to the solution really quickly. But if I don't comprehend your instructions very well, I basically have to reanalyze it and kind of, like, actually, like, see what I have to see. And sometimes when I don't see it, it just gets me flustered. It's mainly me, though. So... What was I doing? Oh, yeah, this. So R is... So we got... So there's two types of R. There's the one that's negative, and there's the one that's positive. Now... the question is, so if that's, so then it will be 3 here. Oops. Then it's 3 to the square root equals 0. Yeah, that's practically right. So practically. Okay. So that's 0. So now. So now we actually have to solve for the whole thing. So practically, yeah. So minus. So y is actually equal to whatever we got. So it's practically equal to, yeah, this. Probably plus a constant or something, right? Or probably nothing, right? Thanks, Fembox. Yx is equal to c1 and c2 for the negative square root. Yeah, because there's 2 roots. Yeah, there's 2 distinct roots. Okay, so yeah. So we just solved the equation right there, so. Okay. Actually, now that I think of it, when r is equal to, you have to make the 2 solutions linearly independent. And you do that by introducing x to one of the solutions. Okay, let's just think back. Let's just think back for a second. Okay. Now I gotta get my thought process connected, because like, because I'm really appreciating your help, Tyrion, but at the same time, it's like, I feel like I'm trying to connect with your thought process, but my thought process hasn't caught up yet. So I feel like I feel like my thought process is not catching up to yours yet. So I'm just trying to reconnect it. So be patient with me, because I'm still like on this part, and I know like we basically showed that because it's supposed to be y times, and y, we concluded that y is equal to, must be equal to that. But at the same time, I don't think that's really what we needed to do here. For this problem, you're doing the general solution as well. For the previous problem, for this problem, you're doing the most general solution. Right. C2 E negative 3. I gotta take a look at, because for some reason I don't know why I'm like fizzing out. Like I'm trying to actually see why that makes sense. Okay, all right, here. This is what I was looking for. You did the auxiliary equation like this. R1 and R2, okay. Okay. Yeah, it's a linear combination, okay. I don't know why I was like kind of like going like bonkers with it. And I think we can like actually check here. So let's go down here. Oh, don't tell me the pages reload all the time whenever I go down here. Yeah, they reload every time. Oh my goodness. I wish I could find a better PDF that actually has like a bookmark like version of this, so I don't have to like continuously scroll down this. There we go. I was like, where are the answers? Here we go. So, oh, they don't have B. So, I guess we can't check that one. But I'm guessing this is correct because we just checked the definition of it. So, I think that should be okay. So here we're going back to page 33. Okay, so we'll go to C. I have these other books up here just in case we have to practice like equations more, like ordinary differential equations. So let's go down here. So we got C, and C is, it's practically, is it? Oh no, it's just different, like with a plus instead of a minus. So yeah, so it's then you do this. Ooh, that becomes a problem. Because with minus, it's just easier to take it away. But now we have a plus, so now we gotta think of a square that actually, because we can't put a negative number, because that's not gonna do anything. Or I guess boundary conditions, since you're taking the, you can check, plug it in. You need to remember also what to do when you have a repeated root as a solution. Imaginary solution, huh? Because I know there is a way to do that. Just making sure that I got the thought process correct. So we have R2 and R1. They're both imaginary roots. So B1 should be 2. Alpha and beta. So that's good that you feel a little bit better, Famish. Exercise is really good for you, and have not been taking care of myself. All that, well, at least you're taking care of yourself now, so. Typically you use cosine X. It's just that, like, if it's supposed to be imaginary, it's just that R is not, like, gotta remember to exercise at least 2 to 3 times a week. Intense workout sessions. Yeah, like, for me, it's like, I've been trying to exercise at least 6 times a week, like, and usually each session is, like, around 40 minutes, so, you know. Like, I would say, like, yeah, start, like, slow. Like, start slow and just do it, like, 2 to 3 times a week, and then you can work your way up from there. Let's see. But isn't that like Tyrion, isn't that though what was I'm thinking? Isn't that the hyperbolic expressions? I'm probably like wilding out. Like I'm probably like not thinking of the right thing here. I'm just writing the stuff that you just typed out just to see it for myself. Oops. I think it's supposed to be minus. Oops, not factorial. Hyperbolic expressions don't have imaginary exponents. I mean, it looks similar to me. That's why I asked. Yeah, I'm thinking Monday and Wednesday and Fridays. Oh, that's good. Yeah. Yeah, take it one workout at a time. Cos is divided by 2 and sine is divided by I2. Yeah, Tyrion, I feel like you're like on a whole other level because I'm like, dang, why am I not seeing the stuff that you're seeing? Maybe it's because you probably know more tricks than me. Because right now, like, I'm in a little bit of a... I'm trying to see what you're seeing. At the same time, it's like, I just can't get over... I can't get over the fact that, like, this R here, I know it's not an I. It's like there's no I in the R that we have here. So, I know you're saying turn it imaginary, but at the same time, I'm like... And I know, basically, like, it's supposed to be, like, Euler's formula, where we're dealing with, like, I think it's, like, cosine of... What was it, like cosine of pi r or something like that? Actually, what does it say here? Because they're supposed to be using Euler's formula, right? Yeah, it's like... Yeah, it's supposed to be like this. I think it's because for me, I don't see it, that's why. Like, I don't see the I, and the I, like, I usually associate it with, like, Euler's formula. Euler, right? Euler, yeah. Sorry. I keep saying the wrong thing. I think it's because I'm getting flustered. Because I'm trying to make the connections that you're suggesting, Tyrion, but at the same time, I'm like, I feel like I'm just kind of like, I feel like I'm not making the connections. That's the reason why. Yeah, Euler. I gotta remember that. I think it's because, like, I'm just, like, basically trying to figure out the problem. Or, like, I'm trying to see what, like, everyone else is telling me to see. So you say... Okay. Yeah, that makes more sense, yeah. Alright, so in this case, then, that means we get C1E. And I think we have to change it to, like, sines, I think. I mean, we changed this to, like, the actual Euler's formula. Now, once you write the solution, there's a way to convert it to real solutions by Euler's identity. You don't have to. One is negative and the other is positive. Oh yeah, that's right, because it's the square root. So... Okay. So C1, we have... So cosine of 0, it would be like 1, because we don't have, like, we don't have an alpha. So I think so it's like 1 plus I beta, which is this. Or was it like beta of x? Oh, they're both beta of x, okay. This, but then that would be 1 if it's like alpha. It's like, yeah, because there's no alpha in here. There's only like a beta in there. So yeah, that would be turned into 0 and that would make it 1. So then cosine of x plus sine of, oops, not I, it's supposed to be x, and plus 2, and then that's supposed to be negative, so negative I thought that's what the square does. No, I just want this. This is what happens when I write so crooked. It doesn't work out. Okay, there we go. That's what I wanted to do. Do it like that. Okay. All right, let's continue. So sine of minus x. All these, the real parts with the imaginary parts. Let's bring this down. Let's do C1. That, and then plus C2 I sine one more session of exercise. Nice. Now you need the fact that negative sine is sine and cosine is equal to negative cosine. I think I asked before, but are you using an iPad? No, I'm not using an iPad. I'm actually just using like a Goemon a tablet. Oh, and we finished. I mean, it's I didn't like I said, like I didn't hear, I don't hear like the bell ring when it's like break time. But it usually happens whenever. Sorry, negative sine is sine. Yeah, it's okay. It's okay. I thought that was rather strange. I was like don't you mean the opposite? Yeah, so we have to do... I'm just gonna finish writing this up. So, oops, I forgot that So, yeah, negative sign, so cosine. We'll clean this up. So it's sine. And then plus. Should be like that, actually. This is where we actually turn it into and this is when we factor everything out. So actually, it should be 2. No. And then cosine of guess that's it. Sine is odd, and yeah, cosine is even. Yeah, that I remember. Yeah, because then we do that and that. Yeah, that's what I thought. It was funny because I was like, wait a minute. It should be the opposite way. Okay, I guess that would be it for today's session, guys. Hopefully you guys enjoyed that. Like, Tyrion, I really thank you for all your help and everything like that. Like, I always feel like you're going at 10 times the speed I am because you see these connections and I'm like, why can't I see the connections you're making? And like I apologize, like, basically, like, I don't get, actually, the other constant is... Let's see. Oh yeah. Right. You're right. Yeah, because then we took the. Yeah, because we removed the negative sign here. So if you remove the negative sign from this side, this becomes negative, and no, this becomes positive, and this one would become. Wait. No problem, Venvox. Actually, the is equal to another constant. Is also another oh, okay, that's what you meant. Okay, now I think I know what you're talking about. Okay, never mind. I was like mixing myself up here. So yeah. You're right. There's a way to make this more cleaner. That's what you're saying to me. So yeah, it's supposed to be cosine of. We can put that as C1, and then plus C2 for. Well, actually, it's supposed to be negative. So this is supposed to be negative here. So negative. We'll put the I in front here. Sine of -3. Yeah, it's supposed to be this. Yeah, we probably should have put K. K would have been a lot more visible to see. Okay. Well, thanks for joining me, guys. Like I said, like, you know, I usually try to do like 2 study sessions. is a constant. The minus can't be absorbed by the constant. Oh yeah, that's also right. Yeah. Yeah, so we can do it that way. Thank you, Tyrion. Yeah, like I said, like whenever you guys help me out, like just be patient with me, because like there are times when like I know you guys like basically are working like 10 times a second, and I'm like, oh, why am I not seeing what you're talking about? Oh, hey, Penn Center. We just finished our like our second study session. If you guys are not familiar with Penn Center, he is an awesome math streamer as well. Also creates a lot of awesome math content. Mainly, so far, he is streaming his lectures on linear algebra as well as real analysis. No, it's okay. I'm glad you showed up. Like, we still have plenty of time to just chat and just like hang out. Just a nice chill session. It is hard to write down what I'm trying to say. Nah, yeah, it's okay. No, it's not that. It's just that I feel as if like you're my coach and you're like telling me to do stuff, but it's like I'm not doing exactly what you're telling me to do, and I feel like I guess like I just feel pressured, because like for me it's like I think it's because like the way my father raised me, because whenever he gave me instructions and I didn't follow them to the T, he would yell at me, and I would be like, oh no, I'm wasting time, what is it that I need to do? I don't know. And then like you would get more angry with me, like very impatient. And I think that's because like whenever you guys tell me things, I try to actually follow your instructions like perfectly, but if I don't see like what is it that you guys see, I'm like, what is it that I need to do? I'm not seeing the connection here. You know, it's like stuff like that. Because I know you guys are not trying to, like backpedal me when it comes to that stuff, but at the same time, it's like I just want to do you guys proud and actually see the stuff that you guys see and like get the solution, and I actually also know that I can get the solution and correct in my head. So, you know, like that way I understand, that's why I learn, and then I understand and I see what you guys see. That's basically what I'm trying to accomplish, you know. But yeah, like but at least like Penn Center, you're here so I can ask you like what's the best part of your day so far. I always got to make sure that whenever people come, like I should just ask that. You're fine. Interactivity is really crucial in learning. Yeah, because like whenever you told me like I think a part, Tyrion, like I tried to basically make the connections, because like for the for turning the numbers into imaginary, I was like but it's e to the x e to the rx, and I was like, I don't see an like there is no imaginary constant there. So I was like, what did I need to do? But then you said like basically like, oh, it's negative, it's I to the square root of 3, and I was like, okay, yeah, that makes more sense. So my sister just sent me a sourdough starter. I'm excited to make all the sourdoughs. Oh, nice. That's good. Like at least you got something like something nice out of that. That's good. But yeah, like I'm always glad that you always show up Penn Center, even though like it's like we just finished like with the math session though. I know I don't do like that long of study sessions. I probably do like 2 hours worth and a little bit of break afterwards. So like, you know, like during break I still talk about math and stuff. It's not like when it's break time I suddenly say, oh, let's stop talking about math now, let's talk about things like different. You know, because this is Math Spellbook, by the way. Because like what surprises me about my streams is that you guys are just like so ahead of me when it comes to math, and I'm like, wow, like all these people like can teach me stuff. And I know I probably said it on stream many different times, and like, so, you know, like I always feel as if like I have to like keep up the speed. What do we got here? What did you just send here? Euler. I keep saying Euler. Why do I keep saying Euler? It's Euler. Does Euler's formula give oh, okay. see. Yeah, Stacks Exchange always comes in clutch sometimes. Oh, okay, so this is what you were trying to explain. Yeah, because when I saw this, like these expressions, they reminded me of, I think, the hyperbolic expressions. And I was like, those look remarkably similar. Is there a connection to that? Like, is there a connection between, like, these and, the hyperbolic expressions? There is, right? The hyperbolic stuff, yes, without, the I. Yeah. Yeah, it looks similar, right? I don't know if there is a connection there, or maybe it's just a coincidence. But then again, with math, there's hardly any coincidences. Oh, complex variables. Yeah, like we were actually doing, so the problem we were doing, Pen, was this. And like we got up to here, and this is when I was starting to struggle a bit. Because I was like, oh, we got this. But then when you said, when Tyrion said this, I finally got it, and I was like, oh, okay, that's what I need to do. Linear algebra is my one true love. Complex variables is my mistress. Is that complex analysis? Or, like, complex variables is complex analysis, right? Or they're two different courses? Yeah, I use them interchangeably. Oh, okay. Yeah, I know the hyperbolic functions deal with real exponents. Yeah, I know imaginary stuff. I just find it funny that they're remarkably similar, like the way they look. The only difference is that sign has an imaginary imaginary number here, like has I in the bottom. But complex variables is usually intro stuff. Complex analysis is usually functional analysis. Oh, okay. I see. So there is a difference. The exponentials have imaginary I. Oh, yeah, that's also true. That's also true. Yeah, right. I forgot. Yeah, because it's supposed to be minus x and x. I forgot about that. Okay, so we did learn some stuff. We actually got through like some of these equations. So I think tomorrow we're probably going to continue on with number 6. Because number 6 has, I think, like probably like 6 of them, 6 parts to it. No, it actually has a. We have 9 problems to go. Oh no, not 9. I miscounted. Let's see, 3, 4. So we have 7 more to do. Okay. All right. So they kind of gave us the tough ones like in the beginning. These problems I feel like I have no problem with. Of course I have to like, you know, implement everything else, but when I see these I feel like, oh, this one's a little bit easier for me to see. But these I had to actually think about these. Well, actually I think Tyrion basically helped me with the thought process here. Go read about solutions to ODEs with constant coefficients when the root is repeated. Yeah, definitely. I'll definitely do that. Okay. So I think that will conclude today's stream for today, guys. Thanks for joining me. Like I said, if you haven't followed any of the people that basically I shouted out, please give them a follow. They're awesome math streamers if you really like math content. And if you're tuning into the stream for the first time, please drop me a follow. I really appreciate it. I think we're like close to getting 50 followers. So, you know, like if we get 50 followers, maybe we can get hopes to get affiliate on this channel as well. So if you guys are just tuning in for the, like, just tuning into my stream, but you wanted to catch up like on the other stuff that I did during stream and you're just tuning in, you can subscribe to my YouTube channel. So that way you can see my progress throughout. In addition, I'm also going to be streaming on my Uncle Talks channel where I'm going to be playing Hogwarts Legacy. So if you guys just want to see me play video games, you can follow me on my Uncle Talks channel. And if you guys are, like I said, if you guys are new and you want to join our Discord server, you're more than happy to join our Discord server as well. Okay, so that will do it for today, guys. Let's see if we can raid someone. I want to see if there's anyone doing any math content for today. We'll probably give them a good math welcome. So no one on my follower list is on. So let's see if we can find someone who's doing math that I haven't followed yet. Tutor Wizard is on. Oh, Tutor Wizard. Oh, here we go. So I think we can give him a raid. Thanks, Zach. Thanks for the recommendation. Actually, I will also give them a follow as well. So first we'll do the raid command. So you guys can copy that if you like. Alright, so I think we'll proceed with the raid. So I will set it up. Raid into the Tutor Wizard. Yep, I just want to make sure I spelled it right. Alright guys, we're about to raid into the Tutor Wizard's channel. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys tomorrow. So take care, guys. Bye-byes.